In this lesson, students are going to define and identify the properties of special quadrilaterals. So we're going to start off with our definition of a quadrilateral. So a quadrilateral is basically any polygon with four sides, so no curves to it, just four segments connected, and it can really look like anything as long as there's four segments. But we have special quadrilaterals. The first one is a trapezoid. And a trapezoid is a quadrilateral with two parallel sides. Now from here on out I'm going to use the abbreviation for parallel, which is just two lines kind of at an angle. So if I were to draw a trapezoid and mark it up, I would just need the symbol there for parallel. So I have one pair, so two parallel sides, one pair of parallel sides. Now we also have something called an isosceles trapezoid. Oops, and I didn't draw it right. Hold on. Let me make that a little bit better. Okay. An isosceles trapezoid has the non-parallel sides congruent. So it's like an isosceles triangle with the top chopped off. Okay, the next special quadrilateral is a parallelogram. And a parallelogram is defined as a quadrilateral with both pairs of opposite sides parallel. So that's really the basic definition of a parallelogram. That's all you need. Both pairs of opposite sides are parallel. So we have some special parallelograms. And let me see if I can move this up here. Okay, we have three special parallelograms and then another special quadrilateral just to talk about really quickly. And then we'll go into more details on our three special parallelograms. The first one is a rectangle. That is a parallelogram with a right angle. We have a rhombus. That's a parallelogram where all four sides are the same length. And then we have a square. A square is both a rhombus and a rectangle. All four sides are the same length, and we have a right angle. So those are our three special parallelograms. We also have, we're going to have two special quadrilaterals that are not parallelograms. So let me just put that down. Not. Let me write that better. Not parallelograms. So I'm going to shorten parallelograms like this. The two parallel symbols and then ogram, okay? So trapezoid is the first one. We've already talked about that. So that's a quadrilateral, but it's not a parallelogram. The other one is called a kite. And a kite looks like this. It has two pairs of consecutive sides that are congruent. So that is not a parallelogram, but it is a special quadrilateral. So we often make a diagram to kind of show the relationships between everything. So the top thing here, this is our family of quadrilaterals. Make sure I can spell it. And in that family, we have trapezoids by themselves. Under trapezoids, we can draw an isosceles trapezoid. Boom, boom. Okay, so I'll put isos in there for isosceles. Over here, we can add the kite, because it's kind of in a family by itself. So I'll connect there. And then we talk about our parallelograms. So parallelogram is separate from a trapezoid, but under parallelograms we have rectangles, we have rhombuses, and then both of those connect to the square. So in this diagram, and I'll talk more about it in class, basically anything below is a part of everything above. So a square is both a rhombus and a rectangle. A square is a parallelogram. An isosceles trapezoid is a trapezoid. An isosceles trapezoid is a quadrilateral. A rectangle is a parallelogram, but not every rectangle is a square. So it's always from the bottom up where the families are included, like always. Not every rhombus is a square, but every square is a rhombus. So that's kind of how you read that chart. So now we're going to talk about the properties of a parallelogram. The first property is what we talked about before. Both pairs of opposite sides are parallel. But in addition to that, opposite sides are also going to be congruent, and opposite angles are going to be congruent. And then consecutive angles, those are angles that are right next to each other. You could say adjacent angles. Those are going to be supplementary. They're going to add to 180. And then the diagonals bisect each other. So these are all the properties of a parallelogram. And you can use a lot of them. Sometime at the end of the year, we'll do some triangle proofs with parallelograms because you can use these properties in proofs because they're kind of common to the proof stuff that we do. Okay, so when you label, I've talked about this in class, but I don't know if I've shown you. You want to label around the quadrilateral, not left, right, okay? So we can't do that. So if I want to label parallelogram A, B, C, D, it doesn't matter where you start, it doesn't matter which way you go, but you have to go around because that's going to set up the proper labeling for your diagonals. Now I can mark this up with all the properties of a parallelogram. So these markings tell me that opposite sides are parallel. The tick marks tell me that opposite sides are equal. Opposite angles are equal. And then if I move to the second parallelogram here, and I put in the diagonals, again, if I label it A, B, C, D, that means my diagonals are A, C, and DB. The diagonals bisect each other. They are not equal, but they bisect each other. So that's how you can mark up your parallelograms. Okay, so a rectangle has all the properties of a parallelogram, plus the angles are 90 degrees. And because of that, the diagonals in a rectangle are going to be congruent. So if I'm marking up this rectangle, I can put the 90-degree angles in here, and then it would have all the other properties of a parallelogram. Opposite sides are parallel, opposite sides are equal. And just by default, since all the angles are 90, they're automatically going to be opposite angles are equal, and adjacent angles are supplementary. If you look at the diagonals, they bisect each other, but they're also equal. So each one of those segments are going to be equal in length. Okay, next is a rhombus. In a rhombus has all the properties of a parallelogram, plus the diagonals are actually perpendicular. And the diagonals bisect the vertex angles. They are not equal though. So the diagonals bisect the vertex angles. So if I mark up this rhombus, what happens in a rhombus is the diagonals create 4 right triangles. They're going to bisect each other, but they're not equal. All 4 sides are equal, and then the diagonals bisect the corner angles. So these angles right next to each other are going to be congruent and across from each other. Okay, so that's a lot of marks. But if you look at the markings, what you have are 4 right congruent triangles in the rhombus. Finally, a square has the properties of both a rectangle and a rhombus. So it's both of those. And if I were to mark up a square, I now have right angles. All my sides are equal. The diagonals will bisect each other and they're equal, which is different than the rhombus. So I better put 2 tick marks in there. And the diagonals bisect the corner angles. So all of that happens in a square. So we're going to practice some property problems in class, and we'll go over these properties. But here are some very basic questions, okay? In rectangle WXYZ, so first of all, let's draw that. Rectangle WXYZ, right there I know how to label it. I start in one corner, I go around. If you don't do that, your diagonals will not match up. So the diagonals intersect at O. WY is 8, so that entire length of WY, that entire diagonal is 8. And what we know is the diagonals bisect each other and they're equal in a rectangle. So to find all these, all of those are going to be the same length and they're all 4. That's a pretty basic question. I mean, we're going to do some more complicated ones in class, but you kind of get the gist of it. Okay? And the next one I have rhombus math. So let me draw that. A rhombus is like a square that somebody sat on. M-A-T-H. And here we're only dealing with the vertex angles. My drawing is not to scale because I'm given that A is 120, and here I made A the acute angle, but if A is 120 and we want to find the other angles, across from A is also going to be 120. Adjacent to A, these have to add to 180. So that means angle T is 60 degrees and angle M is 60 degrees. So those are the 4 angles. In the same rhombus, find the measure of angle MAH. Well, let me draw this again. I'm going to make it to scale this time, kind of. MATH. So angle MAH is right there. And this is a diagonal which bisects the corner angle. If angle A was 120, then angle A is being chopped in half, and this angle is going to be 60. So those are a couple examples of the basic problems you're going to do. We're going to go over these properties in class, and then you'll do more problems like this.